Hello everyone. So this is the start of the video lecture series that I'm going to be doing for the next possibly couple of weeks for you guys. The videos will be divided into probably like an hour, maybe even less subsections, just so that it's easier for you guys to access. They're easier to download or go and view on YouTube. I'm going to try and upload them onto YouTube as well, so that they're always available for you guys to go back and go over. And the only thing I might need to say is that the recording, my voice might be a little bit on the low end or the low range of volume. I've always had problems with my mic, so please just bear with me. If it's a little bit soft, just turn the, or mute it, just turn the volume button up. So I'm doing this both for second and third year. The third years will be, I've taken a different path with you guys, but for now you're going to start to get into the more professional side of Revit, where we have to get you to just at the very least know the basics of presentation and detailing and construction within Revit, as well as how to control your views, how to make things look good or better, and how to deal with visibility graphics and graphic display options. And then the second years, I'm just going to recap. For the third years, I'm doing this for the first time, I think. But for the second years, this is basically a recap of our lecture the first half of this video is going to be a recap of our lecture last week. And then we're going to move over onto the same things like visibility graphics, which you guys should not have done yet. All right, so we're going to start an empty scene again. I'm going to very quickly do a conceptual model and import it into one of the sample projects. Now, many of you guys would have seen the basic sample project. This is the advanced one. If you do not have access to it or don't know where it is, if you go to Autodesk's website, and you just say search sample project files, they're around 15 megs, so they're really small. You can download these two sample projects from Autodesk's website. Don't need an account, don't need to pay for it, it's free. You need to download the advanced sample project that we're going to be working with today, as well as the basic sample project for us to deal with the visibility graphics. Once you've downloaded that, open them in Revit. Okay. And you guys will see, because this is Revit 19, we have this tab, which is essentially that sort of window, the open windows that we have on the CAD lab that you never see. We almost have it like an explorer here, which is great for us to shift between our projects and our masses and our conceptual families. Okay. Now, I'm not going to do anything here just yet. I want you guys, if you're working along or if you want to quickly just have a look, I'm going to just do a new conceptual mass. Okay. And I'm just going to draw like a square building for now. I'll make it a little bit more complicated. Now, most of you guys should know how to control your dimensions is by selecting specific lines and then using these pop-up dimensions to enter like a new value for what they want. So this building, I'm just going to make 20 meters wide, and in terms of length, I'll make it 32 meters. Okay, nothing fancy, just a square building for now. I'm going to center it around my origin point, so that when I bring it into my model, it pops up where I click. That's the primary reason for that. So if I click there on that shape and extrude it up, I'm going to make this around 15 meters, which is more or less a 5-story building. Okay, and like we've done all the time, I'm just going to make this a weirder looking building, just to make sure that I can show you guys how divided surfaces and curved surfaces also work inside Revit. Okay, it's not enough to just do a straight extrusion. That's not going to show you guys the complexity of the program. So I'm just changing the top profile now, like that. And now I'm just going to play with some of the vertices by clicking on them. I don't want to do too much to this. Okay, so these are 4 curved surfaces now, you guys can see. And then to this, I'm going to add just another rectangle, merge it with the existing building. Whoops, okay, and there I made the mistake of drawing like somewhere around no man's land. I'm just going to undo that, set my work plane as the ground floor, and then draw on that. Okay, extrude that up, sort of like a reception area for this building, and then maybe an exit or a view area here at the back. I'm going to draw that in elevation, so I have to set the vertical plane and draw on it by using this tool. Obviously draw on the work plane, not on a specific face. This is going to be like a viewing deck. And I just want to move it a little bit inwards, like that. Cool. And now because I've got these volumes and this complex shape, actually let's do something weird. Let's bring the ground floor up as well. Okay, so that we kind of have like a reception external landscaping area underneath there. Okay, that's it. And remember, when you want to have mass floors, guys, so today we're going to go through just adding walls and floors and roofs and columns and internal walls to this building rather quickly, and then move over to making things look better. So in order for us to do that, we always have to make sure that our separate volumes are always joined. Okay, and if I click on join under modify, I can now join my volumes. So now I've joined those two, and then those two with that one, and now you can see once we hover over, it's a single volume, and we press tab, it's a single volume. Okay, that is it. I'm going to move this one down a bit, so in case I want to do like a little basement floor on it. Okay, and that's it for now. So I'm going to save this under today, and I have a folder under today where I'm working, and I'm just going to call this concept mass 1. And once I'm happy with that, I'm going to load it into my sample project. Now, once you've opened this project, you will see that it's basically in 3D view, and we don't want to place this mass in 3D view. We want to place it in a plan view or something. And so here are all of our plans currently set up and our levels. And for the third years, I'll go through how to set that up easily. So I'm going to go just to my site plan, okay, and I'm going to go back to my massing and place my mass that I've loaded in. If you say click place mass, there which should be the mass that you've just made. Okay, you guys can see more or less the size of it, where it is. I'm going to place it here more or less inside this precinct for this building. Now let's go to our basic 3D and see how it's looking there. Okay, cool. I'm happy with that. You guys can see it's also placed it at the right height, more or less, as well as the scale is more or less actually right to what I need. So I'm happy with that. Now let us get to grips with the basic for the third years, but it's good for the second years to recap this for adding floor levels to this. So I'm just going to click on my mass and say mass floors, and then there are the levels pre-set up for this project, this example project already. Say OK. There you guys can see those 3 levels popped up. So for some reason the mass that we loaded into this example project is showing as a solid volume. It's not transparent. That's a setting for this example project that they've used, and it's quite useful to have your mass transparent, but I'm not going to fiddle with that now. Once we get to the visibility, the second part of this lecture, we'll show that. And you guys can see it's probably going to need another level. So there are more levels set up, not just 1, 2. I see there's a roof level and a parapet level. So I'm going to click on mass floor again once I've selected my mass, and just add one to the parapet. And yeah, I'm happy with that. That's a good level for my mass. Okay. So I've got those 4 floors. Now, obviously you can model in floors inside Revit in plan just by sketching them. Same with walls, same with roofs, same with floors. We are going to allow Revit to do that automatically to our mass, and this is called the conceptual mass by face method of doing your modeling. Now, again, like last week, guys, I know we've actually been through all of this with, I think, most students, with everyone. So it's good for us to just go through this again, because this is the most important part of your entire process of taking your conceptual volumes, which you've explored and done some crazy or creative stuff in, for example, and then making them real. You want to get to this point. Okay, well, this is a boring building. You don't want to get to that point. You want to get to making your building real. So under architecture, let's start with walls, okay? And once you click on the drop-down menu, there should be an option called wall by face. Excuse me. And that is the option where you can select faces inside your mass, any non-horizontal faces, so it won't select that roof, okay? And apply walls to it. And now there's 2 walls. You have solid walls, which are all of these under the drop-down menu under walls. All of these normal basic walls, okay, which are just solid walls made out of different layers like brickwork, blockwork, concrete, insulation, and then curtain walls, so almost like that, okay, in the example file where you have glass panels and mullions and transoms, okay, as well as storefronts and pavilions walls. So let's just, very important for you to know, curtain walls cannot be applied to curved faces, okay. They can only be applied to straight faces or flat faces. I can show you that. If we try and put an exterior curtain wall onto this curved face, I'm going to get an error. Revit's telling me we can't do that. Okay. So, but look at, if I try and place the wall by face, curtain wall, on a straight face, there we go. No problemo. Okay. So that's the first wall type, or the curtain walls. Okay. You can also then have the generic or basic wall types. These walls, fortunately, you can place on curved faces. So if you go to wall by face and then select one of these basic walls, now you see we can place walls on curved surfaces. Okay. You can put glazing on curved surfaces, and that is the third type of wall, and it's not under walls. It's a little bit irritating, but it's under curtain systems. Okay, now a curtain system you apply to a mass face, and even if it is curved, and then say create system. And what it's going to do in the beginning, it's just going to create the grid, the UV grid. That grid you can always fine tune. So currently it's saying a 1.5 by 3 meter system. That is a German system. We can change it to a 1.2 by 2.4 system, which is the South African standard. So let me show you how to do this. So I'm going to edit this curtain system by clicking edit type, clicking on it, then saying edit type. And now I'm going to teach you guys how to create your own types of anything that already exists inside Revit. Okay, so this applies to walls, doors, floors, windows, anything, trees, anything. You can change their types. So once you clicked on edit type, you will get a window like this, which will tell you how many types there are. Now currently there's only one type of curtain system, and we want to create a new system. So I'm going to click on duplicate. Okay, then there's a, now we have to name it. Okay, so our new type is going to be a 2.4 or a 1.2 by 2.4. That's a South African standard curtain wall system. And under the grids, that relates to these lines. We're going to change grid 1 to 2.4 meters and grid 2 to 1.2 meters. Actually, I want it the other way around, so I'm going to do 1.2 by 2.4. Fixed distance, okay. Once you say okay, there's our new curtain system. Wonderful. Now, currently it's just glass panels without any mullions. And how you can apply mullions to this is by going under architecture, and just by curtain system you will see mullions. Okay. And instead of clicking these lines one by one, you have the option of selecting all the grid lines, and then click, and there are my curtain wall mullions. Now these mullions are preloaded into as a specific type into this example file. If I undo and I go to mullions, I can change the mullion types to, let's say, circular mullions, which is already preloaded in this project. Your default empty standard projects won't have different mullion types. It will only have one. So it's really great to use this project as a template once you start to deal with glazing. And what I'm going to do is just say, let's do a 50 by 150 mullions, quite big mullions. Okay, and happy with that. And that's how you do glass curtain systems on a mass. You don't do it with the wall by face, you do it with the curtain system. I prefer to use curtain walls on the straight faces because they're a little bit more controllable after you want to change them, and then the curtain systems you use on curved faces. And then standard walls you can use on curved faces as well, like we did here. Okay, the only tricky thing is now to put windows and doors in those surfaces, but we'll get to it. Right, excuse me. So now what we can start doing is apply walls to many of these faces, but before I do that I want to show you a little bit of a gripe that I have with what a lot of students do inside Revit, and that is applying actual floors. So now, do you see those red lines that we've applied with the mass floors? Okay, those are just analytical floors. They aren't real floors. They don't have a thickness, as you guys can see. So I want to apply real floors to them. So we're going to do that, and under architecture, go to floor by face. There are a bunch of floors already preloaded or made in this project, and I'm just going to say a 300mm floor, and I'm going to select all of these mass floors that I have for this mass. Okay. Oops, there we go. So create floor, and boom, Revit has made those floors. But look at the following. These floors are all going to the edge of the masses. Okay, so that is an irritating thing, because once we start adding more walls to this model, you will always see these sort of these solid lines of the floors running through the model, and I really hate seeing that. In reality, walls sit on the outside of floors. Floors terminate on the inside of walls. Like you would see here, like that floor in this building is running on the inside of the wall. Can you guys see? It's not going to the outside. So how do we do that with this? So there's three ways of doing that. The first is by just placing the floors like we've done now. Okay. Then going to each floor, saying edit, clicking on them, edit boundary, hovering over to your boundary, pressing tab once, clicking again, and then where it says concrete cantilever, you add a little bit in there. So for a 230 wall, you have to cantilever 230mm inward. And look at what happened when we pressed put in 230 millimeters and pressed enter. Now it's showing us a new dark line on the inside of our main boundary lines, which means is that these floors will always be inset now 230. So if we say finish sketch, can you guys now see that floor is not going to the edge of slab. Well, sorry, the floor is not going to the front face of the slab anymore. Okay, it's sitting now on the inside of this of these walls. But this is sometimes a little bit laborious to do, because now if you've got a 20-story building, you have to go and edit the profile of 20 floors. There's a way of doing it quicker from the beginning. I'm just going to undo everything. Cancel that, edit, cancel. Sorry, to go back a little bit. Before we place the floors. Okay, so here's the mass floors. So now I'm going to redo the floor by face, 200 or 300 thick. I'm going to select those mass floors and look at, and before I say create floor, I have the preloaded offset option. So now if I click on that, 230, and say create floor, it creates all of the floors with a preset inset. Can you guys see? There you go. So there's the mass floor, the red analytical floor that we see there, and that's the inset concrete floors. Okay, so that means that our floors will not go to the edge or past the edges of our walls, and it won't look messy. I don't want to see your models with floors and walls showing up on the edge of the faces of your conceptual masses. That looks terrible, it's unprofessional, and it's actually not how buildings get built in real life. Okay, you have to start looking at the details of how to do these things in the computer digitally, because that's what contractors and consultants will respect. So those are basic floors. Oh, the third way of doing that is, let's say for example, we didn't place the floors with an offset. Okay, if I just place the floors normally, okay, like that. If I, for example, delete that wall and I go to wall by face, and I say, instead of finish face exterior, I will say finish face interior. Then it's placing the wall on the outside. Can you guys see what it's doing? That's the mass face line there. Now it's placing the wall on the outside of the mass face. So essentially now you also won't see those floor lines, because the wall is sitting on the outside. Sorry, we'll get to visibility graphics. Just ignore what I'm doing now. I always do that in these example families. Just ignore. Okay. So now you guys can see it's essentially putting those. Let's just go to, yeah, there you guys can see. So I placed the wall on the outside of the mass face instead of on the inside, and now the walls won't overshoot them. It is up to you how you manage and deal with that all the time. I like insetting my floors and keeping my walls also on the inside of the mass, but that depends entirely upon you as a person. So I'm just going to add a little bit more walls to this. I'm going to do exterior glazing on that mass face, on that one, and on that one, those two. Again guys, this is just me playing around. This is not a good design, okay? Just be very clear. This is not a good design, okay? It's interesting, it's quick, messy study, but it's a lot of gloss. In real life, if you just give us like these fancy curved conceptual masses with curtain wall systems and curtain systems placed everywhere, it's not going to impress us, okay? That's not how you actually do good architecture. So, and I just want to place a wall on the underside of that surface. Let's do brickwork. Okay, it's got some sort of an error there, but I don't know what it's doing. Okay, and then on the top, um, we can either place walls on these curved surfaces, or you can place a floor. So, or a roof. So, same as with where floors and walls, you can have roofs by face. And here's our basic generic 400mm roof, but there's other ones with like cold roofs, bar joist roofs, timber roofs. I'm just going to place a basic cold roof on top of that surface, say create, and there we go. Okay. And yeah, I'm happy with this. This is not, I see there's no wall there, so I'm going to place another brick wall on that face. I'm going to shift it to the interior, to sit on the exterior of that face. You guys will always see sometimes, even though you're putting it on the outside, these floors might overshoot and extrude out from your walls. We don't want to see that. Okay, so that's it as far as my building. Nope, it's another face. And another one. Okay. Oh, and I see these two flat surfaces need to have roofs. So I'm going to go back to roof by face and click on those two areas and place my roofs. And that's my building for now. Now, as you guys know, you can just update your building, and you can always, your mass, sorry, and then all of these things can be updated to your new surface or your new mass. So let's say, for example, if I edit this mass, going back into my mass family, and just change some parameters, okay, making it maybe a little bit more elegant. It's going to give us an error probably, but okay. Okay, now I reload this back into my project. You can load it back into your project or load it back into your project and close it. It doesn't matter what option you select. And now you guys can see that many of the surfaces aren't really like aligned to what this building needs, the mass is anymore. So we can just select our various wall types and floors and mass types. Just say update to face. Okay, update to face. Don't show this message again. It's just telling us that the joints cannot be preserved during your remake, which is fine. We don't want to preserve those joints. And again, these floors can all need to be updated. So I'm just going to select them and say update to face. Now obviously it's a very specific look to keep floors on the inside of a building. Obviously it's very easy for you to now select all of your, say, delete your curtain millions that are irrelevant, to click on your floors, edit the boundaries, and offset them in to the outside. So you use a negative concrete cantilever, so let's say 500. Now it's offsetting the floors to 500, right? Now it's sticking outside of the building, and that's a very specific look. You guys understand what I'm saying? Like some architects do it like that. So whatever it is, your floors must either overshoot your walls or be on the inside of your walls. I don't want to see them on the face of your walls. Okay, I'm going to undo that. So that wall needs to be updated. This one needs to be updated. It's sometimes tricky to remember which ones you've worked on, but it's a good idea to just, yeah, there we go. Why is that? Update. Okay. Got a little bit of an error there, but okay. This one also needs to be updated. This roof needs to be updated. These two floors need to be updated. And that roof and that roof also probably needs to be updated. Okay, no, they are fine actually. Cool. And that's updating your architectural element to your mass faces. Okay. Now let's get to the basics of adding columns and internal walls. And that is when we're going to start looking at our floor plans. Okay, how can I move this up? Okay, I can't. Under your project browser, all of these things can obviously now, we need to start adding a little bit more realism to this, and that's what we're going to do with columns and internal walls. Okay, so if we go to level 1, for example, there is our level 1 for this mass currently. So that's the existing building, and you guys can see they've already taken the effort of detailing this up, etc. Well, let's not worry about what's happening here just now. Let's focus on our own building. Now, columns are found under structure, and then you will find columns. Don't use the architectural columns, they are aesthetic columns. You want structural columns. Once you click on that, you will get this window like this, and it's telling you, okay, what type of column do we want to place. I'm fine with regular I-beams just now, okay, or I-columns, I-sections. And I'm fine with vertical columns just now. We'll look at slanted columns next. And before you place them, you have to choose and tell Revit if you want the column to be placed from this level going downward, which is depth, or from this level going upwards, which is height. I always do height. I want to go place my columns on the level that I'm looking at going up. And I don't actually care to what level it's constraining now to, but let's say we want to go up to level 3. They'll be sticking out and around our building, which I don't care. Now we can't see the floors above, okay, so I'm not going to be placing my columns along a grid now. I just want you guys to experiment more playfully with columns just now. You don't need to be rigorous and like boring like these types of buildings just yet. One day when you're working you can. So I'm going to place a couple of these, just like a bunch of them. Not really caring their spacing, if it's accurate or working properly. Okay, and there you guys can see our columns are chilling at. Now if we go to 3D, can you guys see I'm bringing them up to level 3, which is obviously a static level, and that's when you get these things where the columns are essentially overshooting your walls and stuff like that. You want to essentially have your columns attached to floors, to the underside of floors, right? And how you do that is by selecting your columns after you've placed them. I'm just going to do these 3 now just to show you, illustrate to you guys. And you will always get these 2 options, attach or detach your columns. And you can attach both the column's base, the bottom part of it, or the top. So these 3 columns, I know their tops need to always be attached to the underside of that concrete roof, right? So I'm going to say attach. Make sure it's saying top, and click on the roof. You might get a little error message saying it's attached to a non-structural target. But if you go to wireframe, there you guys can see those columns are now attached to that target, the roof slab. Okay. Let me hide that, delete that wall. And I'm gonna, for now, as we're working with columns, hide my masses. Okay. I do that by clicking on massing and site and say show mass by view settings. And if the view settings are hiding masses, then the masses will be hidden. Okay, so this column here, I want to attach to maybe that slab or even that wall. You can just click on that, say attach, and attach to that roof. Sorry, that's a roof, not a wall. And now it's attaching to that roof. And if I drag a copy of it over around, you will see it won't maintain its attachment, but you can just click and attach, click on the roof, and there my column is now attaching to that roof. And as you move it around, it will always maintain its attachment. Let's try it with this column, for example. I'm going to attach it, and you see I can't select that red wall, obviously, because there isn't anything anymore. Let me just place another wall there. Nope. Okay, it is still there. Never mind. Okay. You can't attach columns to walls. Obviously, you can only attach them to either floors or roofs. So this column I'm going to bring up. Oh, sorry, it's not really intersecting with that roof. So I have to kind of bring it in or attach it to that floor, which is sitting there. Okay. So attach to the roof. And if I hide that wall, just hide it for now, you guys can see that the column should be attaching to that roof whenever you move it underneath that roof. Okay. Now all of these kind of actually have to go up to that roof, or you can attach them to specific floors. Okay. And if that floor changes, so if for example I move this floor around like 1500 upwards, you see that the attached columns move upwards with it, which is really neat to do. Okay. So that's the basic rule of columns. You're going to use the attachment, and again, like we've done tops of columns, you can do the bases of them. So if I click on attach, I'm selecting that column now and I'm saying attach, and then choose my base attachment, and I click on that floor. Look at what happens to its base. It goes up to that floor. So now it's attached to the underside of that and the top of that slab. And it will always move up and down with respect to how these floor slabs move up and down. Okay. And that's it for attaching columns. But now let's look at more interesting ways of doing this, which is like if we want to start crafting this to be a little bit more believable. And how we would do that is essentially slanted columns. So under structure, column, let's choose slanted. And very important is when you're using slanted columns, be in a 3D view. And don't worry about these first click and second clicks. Don't ever use that. That's for structural engineers to use. Use the 3D snapping tool. Okay. And now, as I'm hovering over to these existing columns, okay, or the existing floors, okay, I can now draw 3D columns to those corners. Very important for columns, when you're using 3D snapping on slanted columns, you can snap to anywhere on an existing column, its draw line or its endpoints. But with floors, you can only select corners. Okay. Roofs the same. And unfortunately, it doesn't snap to walls. That's actually it's snapping to the roof there. It won't really snap to walls. You guys can see where two walls come together. It's actually a really neat join. You can't snap to them, which is unfortunate. And now it's slanted. 3D snapping is turned on. I'm just going to draw a column from there to the endpoint there. And there we go. Now you can draw many other columns. So let's draw one from there to the edge of slab there. Okay. Maybe we need one from there to there, and from there to there. So now you can start adding believability to your project structurally. Now, this is not a believable structural grid I'm using. It's an interesting one. I'm starting to figure out the tension lines in this one, which kind of probably has to do this. Okay. But so this is just to getting to grips with slanted columns. I really like using it because structural stability is very important in buildings, and especially if you guys are going to be modeling up really organic or extreme shapes in your conceptual modeling workflows, you need to kind of make them believable. You can't have floating buildings and floating stories 70 meters long without any supports or cross grids or bracing or anything. Okay. We want to see you guys think about your crazy conceptual designs and then make them more believable. Okay. Now let's start looking at family types. The existing columns in this sample file, I see they have preloaded columns. They've got round columns, concrete columns. They've got these flanges, these eye sections. we can load other types of columns in, and it's the same way you load entourage, like the way we did with people or plants. So you're just going to go to insert, say load family. Obviously you need to be in South Africa family library, and then go to structural columns. Let's add a few wood columns. So I'm going to add a glulam column and just a normal dimensional lumber column. Sometimes when you load columns inside Revit, you can tell Revit which families to load. So these are the types of default thicknesses and sizes. You can make your own ones later, or you can select a preset couple of them. Let's say I need a 64 by 89, I need an 89 by 235, and I need a small one, a 38 by 64. Loading those, nothing's happened yet, but once you select your existing columns now, let's select that one for example, and I'm going to place another one here, going to there, and another one here, and I want to go to the center line of this column. I don't know where the center line is, but I'm going to guess. Okay, and maybe another one from here to there. Okay, so this is not a rational grid. Okay, I'm just playing. Okay, all right. Now you can select anything inside Revit and change its type. So even these windows, I can select, click on the drop-down menu, select another type, and it changes that type. Okay, so the same thing we're going to do with our columns. So this, let's say I'm going to copy select those, control select those three columns, and then on the drop-down menu under columns, there's my new timber columns that I've loaded. I'm just going to change them to timber columns. Okay. So instead of having to place them manually now, we can have existing columns and just change their type, even their family type, to a completely different thing. And it will still remain its attachment, retain its attachment properties as well as its, it will still retain all of its properties as well as its attachment properties. Okay. What's really crazy is that there are some columns which essentially will function as trusses. There are truss systems inside Revit, which I'll show you guys sometime later, or you can experiment with them on your own. I do not like them. These truss systems really overcomplicate things, and they give you errors like you wouldn't believe. So I'm going to I need to show you guys structural connections, but I don't know if these ones will actually work. This is quite a messy selection, and if we go to modify, there's this little button called beam column joins. Now when you click on that, everything is sort of going to go gray, and then you might find a few areas where we have these arrows. Now that only works with columns that are placed vertically and horizontally. Then you can change how they match. So if we look at these concrete joints, beams that they've drawn here at the bottom, you look at these arrows. If you join the arrows, then you get mitered connections, okay, or like a beveled connection to a certain edge, or an open miter connection. So those are beam and column joints, and they work. Like I was a bit sillier, I placed my columns on a diagonal sort of 3D snapping line, so they won't get those connections. But if, for example, we add beams, okay, beams also work like with 3D snapping options. I'm just going to place a flange from that column to that one. So that's a beam now. Obviously beams and columns are right next to each other, so it's important to use the different types of families in the situations where you need them. Maybe now if we say no, okay, it needs to be the same family, exactly the same family, and it needs to be the exact same shape, then you can do different connection joints, which will, I kind of don't like messy joints like this. There is a an option called coping, which you cut steel beams with another one or columns with another one. So you click on, you go to modify. Sorry, I just need to reset that. Okay. Go to cope. Then click on the first one which you want to cope, and then on the second one which is supposed to cut it. And you see it's cutting back. Okay. And you can set that coping distance by clicking on the column, and it should be somewhere. Coping distance. If you change it to 5 mils, then it's cutting back to 5 mils. Okay. So you can be very particular and accurate with columns inside Revit. Let's try it this way around. It's not really looking great. I'm sorry for my cat. And yeah, so you can cut your or cope your structural columns like that. Alright, that's the basics of columns and beams. Beams work exactly like slanted columns, so they use a 3D snapping tool set. Okay. Don't place them. So I like placing my beams and columns in 3D views because it's so hard in floor plans to place beams and columns. You don't know where they're snapping to. They place them at all of the weird places. Unless you're placing 100 beams at a specific level where you know you're going to, like inside this building, for example, in a grid, then you can do it in a floor plan. But if you are exploring or experimenting conceptually with a mass and its structural stability, maybe it's a good idea to just use the 3D snapping toolset. Just one thing I forgot, if we go to beams and we load, under structural framing, there should be trusses actually. Yeah, go to steel, and here are preloaded girders and trusses. So they also give a lot of errors because they are quite complicated and complex. But let's try one. I'm just going to try this one, DLH. So that is the depth of the beam. Okay, so it's a 1.3 meter deep beam. Okay, keeping 3D snapping on, let's see what happens if I try and join that point to that point. Okay, and there's my truss. Now trusses will show as model lines to keep the file light, and until you change the specific view's detail level to fine. And that option you can find at the very bottom here, under all of these weird colorful lines, which we'll get to in our second part of this lecture. It'll be the first option next to the scale, and currently we're at medium. And if we put it on fine, there's my truss properly displayed now. So there are many types of trusses, obviously. So if I go back to beams and I just load, let's see, there's castellated beams, these ones, cellular or castellated beams. That's a cellular, castellated as a different cut. Round bars, obviously, which is important. L sections, very important for bracing. They're cheap and strong in a specific direction. Double eyes or double lips, T channels essentially. C channels, very important for roofing. And these are double pitch trusses. Let's see, they're not really going to work if you're drawing some. Let me illustrate. 7 panel, 2 meters deep. So these are big trusses. And I'm just going to draw from that point to that point. Yeah, you'll sometimes get these errors which just says, sorry dude, we can't create this truss at the angle that you've specified. They are complicated families. They generally work well if you try and draw them on a flat surface, like from there to there. Even then you get an error. If you do get an error, try and load another family. But again, I'm not going to play around too much with this. We need to get on Let's try that one. 500 deep. And there we go. There's our truss. Okay. So you can really get into a lot of detail with modeling with trusses and structural systems. Now, this obviously is a big building and there should be internal walls. There should be. Okay. Yes, this thing is ugly. So, like we've drawn walls by face, you can always just draw walls in plan, which is called architectural walls. Okay. So I know that is level, the parapet roof level, or let's draw on that level, the third floor. I'm going to go to my third floor plan. There's my floor slab. Obviously you guys can see it. So I'm going to go to wall, architectural, and I'm going to draw it more or less. Let's just draw a generic masonry wall. Okay. Now, walls work exactly like columns. It has a base constraint from what level you are drawing it from. There you guys can see. And it has a top constraint. You can draw them as rectangles, lines, arcs, and circles, and polygons. Okay. We are just going to be really simple about this. We are just going to draw basic wall. Now, obviously, again, this is a really ugly design. I am just illustrating the program's technical specifics. Please don't think that these are in any way good architectural designs. And there our walls are. Now, walls, as you've seen, if we click on a wall and we look at our property panels, there we can control its level and its height. So if it's relating to a specific level, which it is doing now, you guys can see that's where it's going to. I'm going to hide the topography. It's constantly getting in my way. Okay. Now we can offset it by dragging it with these little handles. Okay, change its height like that. You guys can see there the offset is changing. You can enter a numerical value directly like that if you know what it needs to be. You can change its level to level 3. It won't work because it's starting at level 3. Okay, so level 3 plus 500. Then we know that's how far it's going. Or you can keep it unconnected and just play around with that shape handle. But exactly like columns, you can use, you can attach it. So once you click on the wall, I can click attach to roof, and there, that wall is now attaching to that roof. Attach to floor. Oops, sorry. You can actually attach it to beams as well, but we're not going to do it. Oh no, you can't. I thought you could. You can attach it to floors. So now I've moved it down to that floor. Okay. And again, like any other thing, you can attach a column, you can attach its base as well. So let's attach the top to that roof. You have to detach it then from this floor, otherwise it's going to maintain its attachment to the first thing which it hits, which is this floor. So I'm going to detach it from the floor. Now it's going to go up to the roof, and I'm going to attach the base to that floor, and now it's going to sit there. So whatever I do with it, if I move it around, can you guys see? It's maintaining its attachment to the things below and above it. I'm going to detach it from this floor, keep it on that level because I want to share something. Walls work exactly like lines. So you can trim. Okay, if you click on a wall, you can trim walls with the trim tool, exactly like you would trim lines, extend them, break them up. You can split them by pressing SL for slice. Okay, and you get a little cutting knife. Click there, click there. You can move them around, angle them. You can do anything with them like you would do with normal model lines in your conceptual mass family. Okay. And again, once you've you're happy with where they need to be. Now I'm just going to attach my wall to things which it needs to attach to. Okay. So that is the basics of attachments. What's really great is like you guys see this wall here. If I extend it out further, I've clicked on attach to roof. It's only going to do that if the roof is there. So wherever this wall isn't below the roof, it's not going to go up and attach to the roof. That's a really great feature. Sorry about that. I don't know why it's doing that. Anyway, so those are the basics of walls, and exactly like anything else inside Revit, you can turn it into glazing, or you can turn it into shop fronts, storefronts, anything which is preloaded into Revit. I think that's the first part of this lecture. It's going to be a three-part. So the next one, just going to talk about beam systems. Now that's one way of doing your adaptive components, but doing it inside your Revit project. So it's definitely not a replacement for adaptive components. This is very important. Okay, beam systems can only be applied to straight faces, and it can also only be used with existing loaded columns. It can't be complex families for the third years, like I've shown you guys with adaptive components. Second years, it's very important for you guys to look at the next few sections so that we can look at getting grips to the more basic functionality part of Revit's structural and typical elements workflow. So I'll see you guys in the next section.